Hello, Miss Doolittle. Where did we end yesterday?
On the types of constructed wetlands, Professor. You were planning to talk about them today.
Okay, let's start with them.
Here, it should be noted that all types of constructed wetlands have two common functional features. The first is the water flow in the wetland, and the second, the density of the vegetation that is a part of the construction. Surface flow constructed wetland or free water flow constructed wetland. A surface flow constructed wetland is a rectangular flowing water basin with a depth of up to 1.5 meters and has a length to width ratio between 3:1 and 4:1. The distinct features of surface flow constructed wetland include: the first, aeration via an open water surface. The second is the formation of silt through the sedimentation of the suspended materials at the bottom. And the third is the filtration, which is performed with plant stems rather than sand and gravel used in other types of constructed wetlands. Surface flow constructed wetlands are mainly used for the treatment of agricultural and stormwater runoffs, as those have the highest concentration of suspended substances. A surface flow constructed wetlands is much more reliable than other types of constructed wetlands. It's more resistant to colmatation, or in other words, clogging. The second type of constructed wetland is the horizontal subsurface flow constructed wetland. The hallmark of this wetland is substrate, consisting of gravel, pebbles, and sand with 50% porosity. The recommended dimensions for this constructed wetland by engineer ecologists are as follows: the depth up to 1 meter, width to length ratio between 1:3 and 2:5.
Excuse me, Professor, what is porosity?
It is the share of voids in percent per unit of gravel volume. The voids between gravel pieces, which make up about 50% of the wetland bed, are occupied by flowing water. And as you may guess, Miss Doolittle, plant roots penetrate these gravel voids approximately at half the depth of the constructed wetland. Horizontal subsurface flow constructed wetlands are mainly used for the treatment of municipal and domestic wastewaters, as this type of constructed wetland removes not only organic substances from water, but also nitrogen and phosphorus. The third type of constructed wetland is the vertical subsurface flow constructed wetland. This type of constructed wetland has the same basic features typical in all constructed wetlands. At the same time, it has its own distinguishing characteristics. First, the water flow under treatment is directed not horizontally from inlet to outlet, but vertically, as a free-falling flow which diffuses uniformly throughout the entire volume of the constructed wetland. Second, this type of constructed wetland usually has a 4-layered structure. The first layer, from the very bottom, consists of the gravel from 3 to 8 centimeters in diameter. The depth of the layer is about 50 to 80 centimeters. The second layer consists of the gravel from 1 to 3 centimeters in diameter, and its depth is about 20 centimeters. The third layer is a coarse-grained sand, and it has also a depth about 20 centimeters. And finally, the fourth, or the top layer, is composed of coarse gravel, 8 to 10 centimeters in diameter, which lies on the wetland surface. Vegetation is planted in the third, sand layer, with the roots penetrating into the second and first layer of the bed as they grow. Treated water leaves the wetland from the bottom layer via pipes. Additionally, there is a fifth layer formed above the fourth layer, which consists of suspended solids as a result of the wastewater treatment. The depth of this constructed wetland is about 1 meter, sometimes up to 1.5 meters. Its length and width depend on the hydraulic load, and, as a rule, they are usually equal. Vertical subsurface flow constructed wetlands are effectively applied for the treatment of municipal and domestic wastewaters, which contain a high content of suspended substances. Any questions, Miss Doolittle?
No, Professor. I think the last type of constructed wetland will be the most interesting.
You can decide that yourself. The fourth, And the last type of constructed wetland is, in fact, a hybrid system. It is an arrangement and combination of the previously discussed constructed wetlands into variations based on the technical requirements necessary for a particular type of pollution. For example, first, subsequent combination via pipes or canals of the third and second types of constructed wetlands, vertical subsurface flow and horizontal subsurface flow, considerably increases the removal efficiency of nitrogen from agricultural and domestic wastewaters. Another example, combining the first and second types into one system is the most suitable way to remove suspended organic material from wastewater, or, which is interesting, 3 constructed wetlands of the second type, horizontal subsurface flow, connected in parallel using pipes, regulate the overall water system in such a way that during the period of excessive hydraulic load, the treated water will not overflow the borders of a wetland cell. It should be noted that the fourth hybrid type of constructed wetlands considerably enhances the functional benefits of each wetland united into system and, moreover, offsets the shortcomings and weak points of the other parts of the system. Hybrid constructed wetlands are used for the treatment of all of the above-mentioned type of wastewaters, including industrial wastewaters. So, Betsy, may I conclude that we have covered the topic types of constructed wetlands?
Absolutely, Professor. I have one question, Professor. How is this classification related to the section that we are covering today, sorption and biofilm?
Miss Doolittle, I had hoped you would figure it out. Okay, I'll give you a hint. Can you remember what sorption is? We definitely discussed that topic.
Of course. Sorption can be defined as the process of fixation of various substances by liquids or solids from the environment. The sorbed substance is called sorbate and the sorbic liquids or solids is called sorbent.
Absolutely right. Now, which treatment system did we consider to study the sorption process?
Activated sludge. Through sorption, such treatment facilities remove...
One moment, Betsy. I'm taking notes.
A reactor with activated sludge removes pollutants such as phosphorus compounds, salts of various metals, including heavy metal salts, and xenobiotics through sorption. These chemically unchanged pollutants are sorbed by the activated sludge particles, making them heavy, and they are then deposited in the bottom of the secondary sedimentation tanks and removed from the treatment facility with the excess activated sludge. That's how sorption works in activated sludge reactors.
Thank you, Miss Doolittle. I have no objections. Now let me tell you about the topic we didn't cover, the processes of sorption in constructed wetlands. The sorption process in constructed wetlands is completely different from the sorption in activated sludge reactors. In activated sludge reactors, the sorption surface is uniform, whereas in any constructed wetland, it's divided into 4 main types. First, the plant stems and roots submerged into a constructed wetland. Second, the substrate, that is gravel and sand. Third, the layer of organic matter accumulated at the bottom or the wetland surface during the treatment process. Fourth, the detritus particles which carry microbial communities and which are transferred within a constructed wetland through water flow. Unlike activated sludge reactors, constructed wetlands do not remove sorbates straight away with excessive biomass. They may remain in the constructed wetland for a long time. Pollutants which are retained by sorbents undergo transformation within the wetlands in years.
As we know, there are 2 types of pollutants. The first type are non-biodegradable substances which should be diluted or transferred into an inert state. They include heavy metal salts and phosphorus compounds. As for biodegradable substances, these are organic toxicants. For example, pesticides, pharmaceuticals, or household chemicals. Taking that into account, I have 2 related questions for you.
Question 1. If having the exact same volume, which of the first 3 types of constructed wetlands, surface flow, horizontal subsurface flow, or vertical subsurface flow, has the smallest sorption surface? Question 2. What is a mathematical relationship, direct or inverse, between the water treatment efficiency and specific sorption surface of any treatment facility, given that all other technological parameters are the same? Take your time to think it over.
I have the answer, Professor. The questions are not that difficult.
Go ahead, Miss Doolittle.
The answer to the first question is the following. The smallest sorption surface belongs to the surface flow wetlands because the sorbents are represented by stems and roots of the wetland vegetation, although the specific surface area of the vegetation is far smaller than the total sorption surface in the substrate, which is used in the subsurface flow wetlands. Now the answer to the second question. There is direct mathematical relationship between the specific sorption surface of any treatment facilities and its water treatment efficiency.
Well done, Miss Doolittle. Now it's time to switch to biofilms. What does that have to do with all we've been discussing here?
Biofilm is a community of microorganisms occupying a surface. These microorganisms are also immersed in extracellular polymeric substance. The process of biofilm development is commonly called biofouling.
Thank you, Ms. Doolittle. It should be emphasized that biofilms in constructed wetlands play a decisive role in treating wastewater. Moreover, biofilms are considered to be the sort of a single organism.
There are 4 stages of biofilm formation. Stage 1. Adhesion. That is the settling of a solid surface by microorganisms contained in the treated water. Stage 2. The attached microorganisms produce an extracellular viscous polymer to which more and more microorganisms then adhere. Stage 3. Colonies of microorganisms bound with a viscous polymer are merged into a single layer, the primary layer of biofilm. Stage 4. A multi-layer structure is formed that spreads to the other surfaces of the constructed wetland. Betsy, in this context, I'd like to ask you a tricky question.
Yes, Professor.
Let's assume that the water in the reactor contains dissolved oxygen. Which microorganisms, aerobic or anaerobic ones, form this biofilm?
Both, sir.
Under these conditions, the outer layer of biofilm is aerobic, as it absorbs all dissolved oxygen coming to its surface. The inner layer of biofilm, whether they like it or not, have to be anaerobic. There is no free oxygen left for them.
Very clever, Miss Doolittle.
Thank you, Professor. But I also have a question for you. Could you please explain the role of plants in the formation of aerobic and anaerobic processes occurring in constructed wetlands? Because wetlands, whatever the type is, virtually always consist of plants.
I've explained it to you with a great pleasure. But tomorrow. Please, write down your question on the board.
Okay, sure. Goodbye.
Goodbye.